Let's take a look at parametric equations for a cycloid. Now a curve which is determined by the point P, which is on the circumference of a circle with a radius of r, so the circle has a radius of r. As the circle is rolling along a straight line, the curve that's formed by that point P as it's moving along the circumference of the circle is what's referred to as a cycloid. So let's just take a look, draw a quick picture so we get a feeling for just what it is I just said. So I have this circle sitting here. And I'm going to start here at the origin, and I'm going to say that is my point P. That point is going to stay fixed on the circle. As I roll this circle, this point P comes up and is maybe roughly here on the circle now as it's rolling along. It was down here. I roll it. It's going to come up. Keep rolling this circle. And perhaps now this point is like over here somewhere. And then I keep rolling it until it goes around once. This point P is now down here. And of course I have my radius of r that stays constant, even though I didn't draw it that way. Well, if I connect the dots, what I end up with is a curve that looks something like this. And the distance that I traveled here was actually from 0 to 2 pi. So by taking that point on the circle and rotating or this circle or moving it along the x-axis, this point's gone all the way around the circle once, which curves out or carves out an arc. So if I were to repeat this to 4 pi, in theory it should come up like this again and give me another arc. So your textbook provides a derivation for these equations, and I would encourage you to take a look at it and see where these actually come from. I'm not going to go through the derivation here. But the cycloid is defined as x equals r, where r is that radius, times theta minus sine of theta, where y is r times 1 minus cosine of theta. Obviously, theta is a real number. So what I'm going to do is break out Maple here, and let's experiment and see what happens with different values of r, and change the domain and kind of fiddle with it a little bit. So here I have r equals 1, and then I have the plot function to plot a parametric curve in Maple. And I have r times theta minus sine theta, that's x. R times 1 minus cosine theta, that's y. I'm going to let theta go from 0 to 2 pi. Now we know that should be one arc. So let's take a look and see what we get. And that's exactly what we got. So what happens now if I go to 3 pi? Think about what should happen. Well, if 0 to 2 pi is one hump, I add another pi, go 3 pi, it should be half an arc. And that's what I get. I get a hump and a half. So what happens now if I start varying my radius? Currently with a radius of 1, I ended up with a height of 2. So if I double my radius, I should go on the y-axis, I should go up to 4. And I did. If I go to 4 pi, I'm going to have 2 complete arcs. So obviously every 2 pi I add, so go to 6 pi, I'm going to get 3 arcs. Let's go to 10 pi, that should give me 2 more arcs, so now I have 5 of them. And so forth. I think you can see, you can fit around with this. Let's just make the radius 0.5 and see what happens. So the radius is a half. And sure enough, twice that is 1. So that's how high my arc is going. In a nutshell, that's really all that cycloids are about. That's all we're going to do with cycloids at this point.